Hi guys, today I'm going to introduce renormalization, group flow, and conformal field theory. I'm Fushan Huang, come from Department of Physics. First, I would like to introduce conformal field theory. If the system is under conformal symmetry, then it can be described by Virasoro algebra. Here, the Ln denote the holomorphic part Virasoro generator, and L bar denote anti-holomorphic part, and it follows like this to three equations. And one object is crucial in conformal field theory, which is primary field. It can be generated by a primary operator acting on vacuum. The primary field following these three equations. If the generator with index 0 add on primary field, it will create the conformal dimension Hi, and the anti-holomorphic part have the similar property. If the index is arbitrary integer n, if the index is positive, then after adding, the result is 0. If the n is negative, it will generate the so-called descendant like this. In the representation theory, it will form the so-called representation space or module. So if we have the primary operator, and if the Virasoro generator with the negative index, and it will generate the descendant state, and all of the descendant states will form this representation space or so-called module. This module is carried by the primary operator and the central charge. Next, I would like to introduce unitary minimal model, and it denotes as M, P, and P plus 1. So the central charge and conformal dimension can be shared with the same parameter P, and the conformal dimension have the two index R and S, and it denotes all of the primary operator in this minimal model. This is so-called Koch formula, and it can be proven that in 2 dimensions, if a system with the scaling invariance, like the fixed point, and it will perform the conformal symmetry. In this case, we can use the minimum model to describe the fixed point. Next is c-theorems. First, we write down the energy momentum tensor T. If the system is translation invariant, the straight tensor is following this equation, and we define the trace operator theta like this. At the fixed point, the system is under conformal symmetry, so straight tensor is traceless, then theta is 0. Next, we introduce complex coordinate on the plane z and z bar, and we define the 2-point function. Here, tau is the norm of z squared and put in logarithmic function. And according to the 2-point function, we can write down the relation between f, h, and g. The dot denote differentiation with respect to tau. And we define c function, which is a linear combination of f, h, and g. According to the previous equation, we know c dot is equals to minus 12g. we know the 2-point function coefficient is positive. So g tau is positive, therefore c dot is negative. Therefore, we prove c decreases monotonically along the RG flow. Next, we introduce Cannon semantic equation for an n-point function like this, where beta is beta function, g is coupling constant. At fixed point, beta function is vanished. Gamma is anonymous dimension. And after a series of derivation, beta satisfy this equation, and we call this is Archer equation. At fixed point, we use g star to denote g, and beta function vanish. Because a system at a fixed point is scaling invariant, so the chess operator is 0. Then both h and g are 0. And the 2-point function of straight tensor can be written like this. C is central charge. Therefore, we know at the fixed point, C function will become central charge. And from the previous discussion, we know the central charge in the UV fixed point, it will larger than the one in IR fixed point. If the system only exists one coupling constant, then C function will follow in this equation. Next, we are going to keep furthermore to introduce the UV CFT with perturbation. So first we consider a unitary minimal model. Here I use the P index, which is referred to the minimal model M, P, and P plus 1. So P is a positive integer from 3. Next, we use a spinless primary operator 513, or we can say it is a thermal operator to perturb MP. Then from the Cox formula, we know the conformal dimension of the primary operator. Then we add an infinitesimal parameter on this conformal dimension and set epsilon equals to 2 over p plus 1, which will be smaller than 1. According to the definition, Archer eigenvalue equaled spacetime's dimension minus scaling dimension, which is 2 minus 2 times h13. It will be 2 epsilon. And by definition, epsilon is positive. Therefore, Archer eigenvalue is positive 2. This implies the theory becomes relevant after perturbation. It will drive the series away from the UV fixed point and go to IR regime. Then we put all information together and we will get this beta function, which describes the theorem away the UV fixed point. And we know at the fixed point, beta function will equals to 0. So we know when the theory flows to IR fixed point, then G star equals to this guys. And we put back to the C function, we'll get this. We will realize this is equals to Cp minus 1. Cp is the central charge denote the UV fixed point, and Cp minus 1 denote the IR1. So we know a minimal model M, P, P plus 1 describe a UV fixed point after perturbed by a thermal operator 513. It will flow to UV and becomes another minimal model MP minus 1 P. An example is when P equals to 4. The UV theory is the tricritical Ising model M45 with the central charge 7/10, and the flow ends at the critical Ising CFT M34 with the central charge 1/2. This is the conclusion. First, we introduce the 2D CFT and we know the critical point. This is the conclusion. First, we introduce the 2D CFT and Virasoro algebra. We know the primary operator and the Virasoro generator. Then we introduce the scaling dimension and central charge for the minimal model. It can be created by Koch formula. Due to the 2D fixed point is scaling invariance, then we know it is under conformal symmetry. So we can use the conformal field theory language to analyze it. By the two-point function of straight tensor and its trace operator, we can define the C function. After analysis, we know C function will decrease monotonically and will be central charge at fixed point. Then we consider a UV fixed point which can describe by a minimal model MP plus 1. We use a primary operator 513 to perturb it, and the theory will flow away from the UV and go to IR. The IR fixed point can be described by MP minus 1P. So this is our conclusion. Thanks for your attention and feel free to contact me if you have any question.